In this section, we're going to focus on solving base E equations. But before we can get into learning how to solve and the mechanics behind it, let's talk about a special condition that will help us solve base E equation. So here I wrote log base E of e to the x power. Now the reason I want to talk about that is because this is one special case to help us solve base E equation. So whenever you have inside a log where the base is the same as the log base, so let me show you. Again, if the base is the same as the log base, then you're simply going to bring down the exponent it has, the x, and just write it as a regular size x. So say that I rewrite log base e as ln, and it inside is e to the x power. When you already have that, then you're just going to bring down the exponent and write it as a regular size. So in this case, e to the x power, when I have ln of it, then I'm just going to bring down the x, write it as a regular size. This will help us solve a base E equation, so that way we can work around it, get it by itself, and then solve for the variable, especially when it's written as an exponent. So make sure you have this note in your notebook before we can start writing and solving base E equations. In this example, when you're trying to solve for the base E equation, what you need to have is make sure that the E function, e to the negative 8x, is by itself on the left side. At the moment it has a minus 6. So we need to have one part on the left side and one part on the right side. If I want to cancel out the minus 6, I'm going to add 6 to both sides. So e to the negative 8x equal 77 plus 6 is 83. Alright, so I'm going to write out the whole step. So here, e to the negative 8x equals 83. Now this step is very similar to what we did in 7.6 when we were solving log equations, or equations where the variable is the exponent. Here I would take the log of both sides, and I'm going to use base E. So on the left side, I have log base E of e to the negative 8x equals log base E of 83. So just like how I mentioned about the special case, if the base is the same as the log base, then I'm just going to write the exponent as a regular size, negative 8x equal log base E of 83. Now, here, again, I'm just showing you how it's all connected to what we did in 7.6. Now, I mentioned about how we can rewrite log base E as ln. So, from here, say we started from here. Again, you see how we start writing log base E on both sides? So instead of log base E, you can write ln of e to the negative 8x equal ln of 83. And then whenever you have ln of e to the power of an exponent, then you're just going to bring down the exponent, write it as a regular size, negative 8x equal ln of 83. And then when you're trying to solve for x, I would divide this by negative 8, both sides. So x equal natural log of 83 over negative 8, and I'm just going to bring a negative in front, so my final answer here is x equal negative natural log of 83 over 8. Now this is what you would write without a calculator, but with the calculator I would just type in at this point right here, I would type in this part in the calculator. So you type in natural log of 83 divided by, and I would put in parentheses on the negative 8 because the 8 is negative. When you type in this calculator, x will be approximately negative 0.5524. So that's the decimal value if you were to type this into the calculator. Let me underline that. But without the calculator, then I just want you to box this. Now, say that you wanted to continue with negative 8x equals log base e of 83. Simple as that. I would divide both sides by negative 8. So x equal log base e of 83 over negative 8. Now again, in the calculator it doesn't have log base e, but it treats log base e as ln. So I would convert log base e into ln of 83 over negative 8. So it's very much the same. So you can continue working and writing in log base e, or from where I drew with this arrow, write ln on both sides, and then work it out to get x by itself, and here's how I would find an answer. Either way works, because again, log base e can be rewritten as ln and vice versa. In this example, I have e to the power of negative 7x plus 2 equals 42. So, in order to start solving this equation, I need to get e to the power of negative 7x by itself. I need to get rid of the plus 2. So in order to cancel out, I'm going to subtract 2 on the left side, subtract 2 on the right side. So e to the power of negative 7x equal to 40. Now from there, I'm going to write in ln on both sides, natural log of e to the power of negative 7x equal to natural log of 40. Since we have natural log of e, I'm going to bring down the exponent, write it as a regular size, so negative 7x equal to natural log of 40. Then I'm going to divide both sides by negative 7 to solve for x. Now if you were to solve this without a calculator, then it simply will be x equal negative in the front, and my numerator natural log of 40 over 7. So that would be my final answer. Let me box that up. Now for the calculator part, you type in what you have here. So you would type this in, natural log of 40 divided by negative 7, but I would put that negative 7 in parentheses. When you type it in, you'll get negative 0.5524. 527. So approximately negative 0.527. So that would be the decimal value if you were to type this into the calculator. But if you don't, then write your final answer in this form and have the negative in front of the fraction if there's a negative either in the numerator or in the denominator. But to review, if you had a negative in the numerator and denominator, you would simplify and the fraction would become positive. In this example, we have negative 4 e to the power of n minus 10 equals to negative 45. Now, in order to get e to be by itself, I need to get rid of this negative 4. The negative 4 is multiplying to the e. So what I'm going to do is I'm going to divide both sides by negative 4. So I'm going to have e to the power of n minus 10 equal. Now, there's nothing in common between 45 and 4, but it's negative 45 divided by negative 4, so it would be a positive 45 over 4. From there, I'm going to do the natural log on both sides. So natural log of e to the power of n minus 10 equal the natural log of 45 over 4 Since we have natural log of e, I'm just going to bring down the exponent, write it as a regular size n minus 10 equal natural log of 45 over 4 and then to get n by itself, I'm going to add 10 to both sides. So my final answer is n equal the natural log of 45 over 4. This is in parentheses plus 10. So that's my final answer. Let me box that up. So if you were to type this into the calculator and you have the function ln within the calculator, then when you type it in, n will be approximately 12.4204. So that would be the decimal value if you were to type in this into the calculator. But again, be very careful with your parentheses. Natural log of 45 over 4 in parentheses, and then plus 10. If you type in correctly, then this should be your answer.